Alright, now we're looking at almost the exact same limit as we had previously. Two small changes. Instead of a minus, we are now looking at a plus. And this is the big thing, instead of going to positive infinity, we're now going to negative infinity. So notice what we have is that the form, as x gets to be very, very large, x squared is a very large positive number. And so this whole thing is going to positive infinity. And then x plus 3 is a very large negative number. And so again, we have the form infinity minus infinity. With both of these examples, if in this one we change the sign, turn it to a minus, then we would have infinity plus infinity, and the whole thing would be going to positive infinity. With the previous one, if we had changed the minus to a plus, the whole thing would be going to positive infinity. Now, we will handle this the exact same way as we did before. We turn it into a fraction, we multiply top and bottom by the conjugate. Now, when we multiply through, we have the limit as x goes to negative infinity of x squared minus 2x minus x plus 3 quantity squared all over the square root of x squared minus 2x minus x plus 3. We already know that we're going to expand it and then divide both sides, both top and bottom, by x. The top is not going to change. We're going to have negative 8x minus 9. The bottom stays as it is. And we multiply top and bottom by 1 over x. And we have exactly what we would expect. This, by the way, is negative infinity. And so this is negative 8 minus 9 over x divided by 1 over x times the square root of x squared minus 2x minus 1 minus 3 over x. Again, let's go to the side and notice what happens, because our instinct is to bring in the x as 1 over x squared and have the square root of 1 minus 2 over x, and then we will be very surprised when we get 1 minus 1 is equal to 0 on the denominator. But this time, remember, x is going to negative infinity, so it's going to be a negative number. If I took this and I tried to write it as the square root of negative 2 squared times the square root of 5, that's not the case. When I try to take the square root of negative 2 squared, square root is going to give me a positive value, a non-negative value to be specific. When I have a square root, it's defined as a value greater than or equal to 0. When I have taken the negative 2 and squared it, the minus sign disappears, not leaving a trace of where it came from. The arithmetic doesn't know that it's supposed to give me the negative square root. So the only thing for me to do is to write this as negative square root of negative 2 squared times root 5, which will give me negative root 20. And so when I try to bring in the 1 over x into the denominator, into the square root in the denominator, I have to artificially put a minus sign outside in order to make this work out. This is there to indicate that my original x was less than 0 because x is going to negative infinity. And now I can go back to finishing this as I did before. Negative 8 minus 9 over x over negative square root of 1 minus 2 over x minus 1 minus 3 over x is negative 8 over negative square root of 1 minus 1 is negative 8 over negative 2, which in this case is positive 4. Always be careful with where your x is headed. Is it going to positive infinity or negative infinity? When you're trying to bring in a negative number into a square root, you have to artificially keep this minus sign outside because the arithmetic is not going to know that this x squared is the square of a negative number rather than a positive one.